So welcome to this short introduction on using Microsoft Excel. Microsoft Excel is one of the most used tools in the workplace. It's used for performing calculations, but it's not limited to doing this. Let's begin by opening Microsoft Excel. And we're going to be using Microsoft Excel version 2007. So what we see in front of us now is a workbook, and the first thing that we notice are the many cells. So each cell can contain a number, or it can also contain a calculation, as we're going to see. So firstly, if you want to put a number in a cell, you simply position your cursor over a cell, click on it, and then type in the number. So if we want 5 to appear here, type in the number 5, and now we press enter. So what we've got is the cell C5 contains the number 5, and C5 is the coordinate of the cell. So let's now perform a simple calculation as if we were using our calculator. So once again, I select my cell, position my cursor over it, and I click. And now what I need to do is to bring my cursor up to the top here, click here, and begin by putting in the equal sign. So we always need to put an equal sign when we're doing a calculation. So let's begin with something really simple like 1 plus 1, so we do 1 plus 1, and when we press enter, we get the result. So let's do another calculation. And we're now going to do 1 plus 1 times 2. So we select our cell, we go to the top, press equals, and 1 plus 1 times 2. In Excel, the little star is a multiplication. So now we press enter, and we get 3. So this means that Excel respects the standard order of operations. So if we have 1 plus 1 times 2, the multiplication is performed first. So 1 times 2 gives 2, and we add 1 to that, so we get 3. And let's now review the order of operations, the standard order of operations. So the first thing that we have is terms inside parentheses or brackets. After that, exponents and roots. Thirdly, multiplication and division, and then addition and subtraction. So if we consider a calculation that's slightly more complex, like the following, so in Excel we need to take care on where we position the parentheses so that we get the desired result. So what we need to enter into Excel is the following. So 5 times, and now we open the parentheses, put in our division 3 over 4, close the parentheses, and put in the exponent. And to put in exponents, we use this symbol, and the exponent is also a fraction which contains a division, so we need to put parentheses again, like that. So the way that Excel computes this now is that it performs the calculation inside the parentheses first. So it's going to do 3 over 4 and the 1 over 3 firstly. And the second thing it's going to do, it's going to raise the 3 over 4 to the power of 1 over 3. And the final thing is it's going to multiply this result times 5. Now if we had made the mistake of forgetting about the parentheses here, Excel would not have calculated the correct result. So let's go back to Excel now and perform this calculation. So we put our cursor over the cell, we click, we go over here, equals, so we have 5 times parentheses 3 over 4, to the exponent of 1 over 3. and it gives this number here. And now let's just do this again, but this time let's make the mistake of forgetting parentheses over the 1 over 3. So we have equals to 5 times 3 over 4 to the power 1 over 3. And let's see the result. So it's quite different, 1.25. And the reason is that what Excel does is that it begins by calculating the 3 over 4, it raises it to the power of 1, and then it multiplies by 5, and then at the very end it divides by 3, which is of course not what we want. So what we're seeing is that Excel is quite a powerful calculator, and it can really do any calculation that your calculator can. So let's now look at another calculation, which is the square root of a number. So if I want to do a square root now, I have to type in the word SQRT, open parentheses, put in our number. So if I put in 16, square root of 16 is 4. Now if you're trying to perform a calculation and there's a symbol that you're not sure of, you can find it here. So you bring your cursor over the fx, which is insert a function, click there, and now you can find the function that you're looking for. So if I'm looking for a logarithm function, what I do is I type in the word logarithm, and now I press enter. And Excel suggests a few possibilities. And to find the one that you're looking for, you simply read the description that's found here. So if I click here, log, so this here is going to return the logarithm of a number to the base you specify. So I've got to put log, the number, and then the base. This one, log 10, well, it's going to return the base 10 logarithm of a number. And if you're looking for a sine function, for instance, you just come here, type the word sine, and there it is. So it's quite easy to find the function that you're looking for in Excel. So let's now use Excel to calculate the area of a circle. So let's begin by reviewing how to find the area of a circle. So the area of a circle is equal to pi r squared. And r can be any number greater than 0. So let's go back to Excel. And what we're going to do here is to calculate the area for different values of r. So I'm going to begin by having a column which I'm going to name r, and I'm going to put in a number for the value of r, and we're going to begin with the number 1. And in the second column, I'm going to call this a. This is where I'm going to calculate the area. So what I've got to do is begin by putting an equal sign. So it's equal to, and it's equal to pi r squared, so I put in pi, and in Excel to get pi you've got to type the word pi and then open parentheses, close parentheses, and now I multiply, and to get my value of r I bring my cursor over the cell that contains the r, I click, and what Excel does is it goes and gets this value. So what we see in our formula bar is C3, and C3 is the coordinate for the value of r. And I take this coordinate and I raise it to the power of 2. So I do our exponent symbol and 2. So this is going to give me the area when r is equal to 1. And it's no surprise that the area in this case is equal to the value of pi, because 1 squared is equal to 1, 1 times pi is equal to pi. The next value of r that I would like to use is 1 greater than the previous value. So what I do is I type equals here, and I get the previous value by clicking it, and then I add 1 to that value. So now I'm at 2. And now what I can do is to get Excel to calculate the new value of the area for the new value of r, simply by clicking on the cell here, going into the corner, and you notice that the cursor changes from a big plus to a small plus. So go in the corner, And what I do is I drag the cell down, and what I've got now is the value of A for the new value of R. So when we drag cells down, what happens automatically is that the coordinate for the cell is incremented. So previously this coordinate was C3. When I dragged it down, it became C4. So now if I go here and I drag this down, the coordinate here, C3, is going to get incremented to C4. So what happens is this. So now I've got C4 plus 1, and C4 is the 2. 2 plus 1 is 3. So now I've got a 3. If I continue like this, my 3 becomes a 4, and I can continue as many times as I want. So now I've got values of R going all the way to 12. And if I want Excel to calculate the corresponding values of A for all these values of R, I simply drag the cell down. And now I've got all the values of A. And now what I'm interested in doing is making a graph of the values of A as a function of R. So the first step is to select our table. And now I go up top, I click on Insert, and now Scatter. And bingo, I've got a graph of my values. Now what we want to do is to edit this graph to make it look a little bit better. So I go over here, Chart Layouts, click here, and we're going to select the first layout. So what I can now do is to put in labels for my x-axis and my y-axis. So our x-axis is R. Go down here. Let's type in R. And let's say the units are in meters. And over here, area. So if the units of R are meters, the units of the area are meters squared. And the title of the graph, we're going to call it A as a function of R. And let's just look at the graph that we've got now. So it's increasing just as a second order polynomial does. So what we've got really is the right side of a parabola. And this is no surprise because A is a function of R, and R is to the power 2.